Okay, hello everyone. We're going to go on into perimeters and more complex perimeters than we did in the previous lesson. And so first of all, we're going to look at circles. So as we look at circles, when you look at the perimeter of a circle, the distance around on a circle is called the circumference. And it is based on the idea of a distance across the circle, or we could also talk about the radius. This is the radius, and the distance across the entire circle through the center is called the diameter. And then we have an interesting number called pi, and pi has this kind of a shape here. The definition of pi is the circumference divided by the diameter. And this is a number that is irrational. That means it goes on and on and on and never stops. But we do use approximations. One approximation for pi is the fraction 22/7, although we don't really use that one very often. The most common one for pi that we use is 3.14. And it goes on and on, 3.1415926. It just keeps going on and on and on. But we, in this course, are just going to use this much of it, 3.14. So when we talk about the circumference of a circle, the circumference, which is C, is equal to pi times diameter. Or you can also say 2 pi r. And the reason why is the diameter is equal to 2 times r, the radius. Or we could say the diameter divided by 2 is equal to the radius. So we can flip back and forth between diameter and radius depending upon which one we don't have. And that's what we use to find the circumference of the circle. So let us say that we have a circle with a radius equal to 6. What is the circumference of that circle? Well, if my radius is 6, I'm going to use this one right here because that's 2 pi r. So 2 times 3.14 times 6, and that's going to give me an answer for that, which is 37.68, and let's say that was 6 meters, so it's meters. And again, you'll have to have labels on these and tell what the unit of measure is. So now let's look at some more complex shapes to do perimeter on. Let's look at this one here. I've got okay, that's kind of what it looks like. So this one is 4 inches. This is 2 inches, 4 inches. It's kind of like a stair step. 2 inches, 4 inches, and actually, no, I put 3 inches on this one, and 3 inches on this one, and another 2 inches. And then this one is 2 inches. But my side here, 2, 4, 6, 8. So this side is 8 inches, 4, 8, and then 6 more is 14 inches on the bottom. So my perimeter for this shape would mean starting at one side and going all the way around. So you have 8 plus 4 plus 2 plus 4 plus 2 plus 3 plus 2 plus 3 plus 2 plus 14. So all you have to do is just keep adding it until you get all the way around. So I've got 12, 14, 18, 20, 23, 26, 30, and 44. So this is 44 inches. It's how long it is to go all the way around that particular shape. Okay, so now let's look at one where we combine some shapes. Okay, we've got a 3-inch radius here, and that's halfway across, so that means this is 6 inches, and I assign this 9 inches. So what we have here is half a circle with a rectangle, okay? So my rectangle, if I want to label each one of the sides, I have 9 and 9 and 6. So for the rectangle part, I've got 9 plus 9 plus 6 plus, this is 3 inches, but the diameter would be 6 inches. So 6 times pi, or 6 pi. So I've got 18 plus 6 would be 24 plus 6 pi, and that pi is 3.14, so 24 plus, let's see, that's 24, carry my 2, 6, 8, and 18.84, giving me 8, 4 plus 8 is 12, and 2 plus 2 is 42.84 inches is how big that would be to go all the way around. Or did I miss add? Let's see. No, I didn't. I did an area on that one in my notes, so that is correct. 42 plus 42.84 inches is my distance around this shape. That's 18 plus 6 is 24. Okay, just checking my math again to make sure it's correct. Let's look and see if we've got some other shapes. Nope, that's all I did in the way of shapes. So you can do a lot of different things. They might have triangles on it. They might put triangles and rectangles together. So what do you do if you have things? Well, you just look at each shape and see what you have to do to find what it is. So that takes care of our perimeter of irregular shapes, of more complex shapes. You just keep going until you get it all the way done. And the more complex it is, the more you have to be careful. Sometimes they'll leave numbers off and you have to look at what it is and figure it out. So let's look at one where we do leave some numbers off. Okay, as you see this one, I didn't quite fill out all the numbers on it. For example, I don't have one over here, but this is the same as that. So now you can fill that one out. And this side and this side are the same, so this one is 20 feet. And this side on the bottom is the sum of this plus this plus this one up here. So 5 plus 5 plus 4 gives you 14 feet for the bottom. Now that we've got all of those numbers figured out, we now will be able to find the perimeter of this shape. So if we start here, we've got 20 plus 4, 8, and that one over there is 12. 5 and 5 is 10, and another 20 and a 14. So therefore we got it all. 20 and 20 is 40, 50. So I have 50, 12 and 14 is 26. So this one is 76 feet is the distance around this shape. So you see, it's just a matter of getting all your sides labeled and then adding it all up. So that's not as hard as you would think it would be. Okay, the next thing we're going to look at is the sum of the angles in polygons. That's also part of this particular assignment. In class, we're going to work with this worksheet here. I'll give you the worksheet, and then together we're going to look at what this is. So let's start with our smallest shape that we have that has that is a polygon, and that is a triangle. And the triangle, we already know it has 3 sides, and the sum of all the angles is 180 degrees. We know that one. We've already talked about that one. Okay, so now let's look at a 4-sided figure. And it doesn't really matter what this 4-sided figure looks like. We are going to, first of all, how many sides does it have? It has 4 sides. Oh, one thing I want here, there's how many triangles? There's 1 triangle. Okay, now this one, by choosing one of our angles, we can make it into 2 triangles. You see those 2 triangles? 2 triangles. Now, each one of these triangles has 180 degrees in it. So 180 plus 180, or 2 times 180, is 360 degrees. Okay, let's go to a 5-sided shape. Again, we're going to choose one angle. This is 5 sides. Choosing one angle, 1, 2. This side connects to every other angle. So that divides this 5-sided figure into 3 triangles. So 3 triangles is 3 times 180, which is 0, 24, 540 degrees. Okay, now let's look at a 6-sided figure. As you see, it's not a very regular 6-sided figure, and I didn't intend it to be. Again, with a 6-sided figure, what do we have? With one angle, you can go 1 to there, 1 to there, and 1 to here. That's not a very good line. Let's see if we can get that line better. That's better. So how many triangles did my 6-sided figure make? 1, 2, 3, 4. 4 triangles, and 4 times 180 is 720 degrees. Okay? Have you noticed a pattern yet? As you go through this, notice that the number of sides, the relationship between the number of sides and the number of triangles. In every single one of the cases, the number of triangles is 2 less than the number of sides. And you always multiply the number of triangles times 180 to get your total degrees inside the polygon. So what's it going to be? Well, in general, it would be n is equal to the number of sides. So our formula for sum of the angles of a polygon What is that equal to? It is equal to n minus 2, because there's 2 less triangles than there are sides, times 180 degrees. That is your basic formula for figuring all that out. So, now what happens when we're given this? We've got that figured out. The next thing they're going to do is start assigning various kinds of variables for the angles in a triangle. And you have to figure out what it would be. So let's look at one of those. We've done it on triangles before in Math 100. And now we're going to look at doing it on others, okay? So let me get an example out here. Oh, maybe I don't have any of those in here. Oh, here's one. Here's a good one. 1, 2, 3, 4, 5, 6. This is a 6-sided figure, and no, it is not a regular polygon. Okay? So, one of my angles is 125 degrees. And then I have x plus 5 and x and 145 degrees and an x, and the last one is x plus 5. Okay? So remember, the 6-sided figure is going to have 720 degrees as the sum of all the angles in that figure. So we're going to have it equal to 720 degrees. So let's write it down. I've got 125 degrees plus x plus 5 plus x plus 145 plus x plus x plus 5. Okay? Now we're going to solve for our x, and then we'll be able to calculate every one of those angles. 125 plus 145 plus 10. Okay, 125, 145 plus 10, because 5 and 5 is 10. That's going to be 10, carry my 1, 6, 7, 8, and 280. So, my whole numbers add to 280. How many of the variables do I have? 1, 2, 3, 4. I have 4x. So 4x plus 280 is equal to 720. And now remember, we have to solve the equation to find out what x is. So you're going to subtract your 280 from both sides to keep your equation balanced. And 4x is going to equal 0, 12 minus that is 4, 6 minus 2 is 4. And now we're going to divide by 4 to find out what x is equal to. X is equal to 110, 110. Okay, so now we can figure out the degrees. X is 110, so this is 110 degrees. This one also is 110 degrees. X plus 5 is equal to 115 degrees. And this one is the same thing. So the angles on this are made up of actually 4 different measurements: 110 degrees, 115 degrees, 125 degrees, and 145 degrees. Those are the measurements of those angles. Since 2 of them, there's 2 110s and 2 115s. So that takes care of that. And that shows you how to use the sum of all the angles of a polygon to figure out what each angle is when they give you a representative expression that matches each one of the angles. Okay, that's it on this lesson. I hope you have a good time with it. Enjoy it. It's a fun one. Okay, thank you. Bye.